Okay. Solving separable differential equations. Sounds like a lot going on here. The key thing will be the separable part. We're going to get things, we're going to separate x's and y's. It's going to feel a little bit like way back in Algebra 1 when you first said, put all the x's on one side and all the y's on the other. It's a little bit like that. The solution to any differential equation is a function, meaning that you can't have y equals plus or minus something. You're going to have to pick which one. That doesn't always happen, but that's why that's there. You got to pick between the plus or minus. Okay, let's do this generically here. dy dx equals f prime. If we move that dx to the other side, which is a little bit iffy because it's not a fraction, dy dx is not a fraction, but we can treat it like one, and that's all we have to really say about that. Just treat it like a fraction from here on, and you'll be fine. That's our separate step. We got x's on one side and y's on the other. And then we'll integrate. So you tell me, what's the antiderivative of dy, or 1 dy? You need to see a 1 there. Who has a derivative of 1? Usually x, but if we're talking about dy, then it would be y. Yep, sorry. And the antiderivative of the derivative of f is just f. The antiderivative and the derivative cancel each other out. F of x. And then plus c because the constant of integration shows up. This is called the general solution because we just have a general idea of what it is. We don't know specifically what it is because we don't know c. In most questions, you'll be given a point that you can use to find the particular solution. So once you find c, then you have your sort of specific particular answer. There's an entire college course devoted to this stuff. So if you're headed toward math and science, in college there's CalcU1. That's the same thing as AB. Then there's CalcU2, right? 1 and 2 put together is CalcBC. Then there's CalcU3, and then there's differential equations, which is what we're doing today, or at least a part of them. After that comes partial differential equations. So, yeah, sure, many of you will stop there, but if you're thinking engineering or science or math, then buckle up, you'll head the whole way down the path. Now, differential equations is a really hard class, but we're only going to solve the separable differential equations. So I'm going to put some quotes on easy. We're going to do the easy ones from that class. If they won't separate, we can't handle them. We'll just leave that alone for now. All right, a separable differential equation can be written in the form f of y dy equals f of x dx. So some function of y, something with y's in it, dy, and then some function of x, something with x's in it, dx. Because we've managed to separate the y stuff from the x stuff. If you can't get them separated, then it's not separable and we won't handle it. To solve a separable differential equation, separate the variables, then integrate both sides. So sort of the mantra is separate, then integrate. Separate, then integrate. Okay, so there's no new concept stuff today. We're going to use everything we already know, calculus and algebra, to solve these things. Number one, solve this differential equation given that the point 0, -4 is on the graph. So already I know that I'm going to use this to find C, but that's sort of at the end. So I need to figure out how to get all the x's on one side and all the y stuff on the other. So let's subtract over the x squared. And then multiply both sides by dx. That's the separate step. Now that we got all our x's on one side and all our y's on the other, we will integrate both sides. And so if I want to integrate the left-hand side, Isabella, what's the antiderivative of 3y? Good, 3y squared over 2. Increase the power by 1, divide by the new power. Then how about on the other side? The antiderivative of x squared? The antiderivative of x squared. So go the other way.
3x.
I like x cubed, but we need to divide by the new, so over 3 or 1/3 x cubed, and then a plus c on that side. Separate, integrate, and then I guess we could say the rest is algebra. So I want to solve for y, and then find c. Maybe we should even add that to our box up here. Separate, integrate, solve for y, and find c. Okay, so to solve for y, let's multiply through by 2/3, first of all. So y squared equals -2/9 x cubed. All right, the next step feels a little bit like magic maybe, but c can be anything. We don't know what c is yet. It could be anything at this point. So if I do 2/3 of anything, I've still got anything. So rather than writing 2/3 c, I'm just going to write c, because I don't know what it is yet. If that bothers you, you can kind of get around that. If you want to put a subscript on it to sort of show that, yeah, those aren't exactly the same thing, but it doesn't really matter yet, then a subscript would help differentiate. But after this one, I'm just going to write c until we find c. Then we'd have to be careful about that. All right, square root both sides. And what do we need to remember when we square root both sides? Plus or minus. Now, it can't be both because it's supposed to be a function. If we have a plus and a minus on there, then this is getting 2 outputs for 1 input. So it's not both. I've got to figure out which one it is. It'll kind of happen on its own as we solve for c. So let's put -4 in for y and 0 in for x. And I bet you can tell already, does it need to be the plus or the minus one? Yeah, if I want -4 for an answer, then I've got to use the negative one. So -4 equals negative square root of c. If I square both sides, I get c equals 16. I can't be done yet because this isn't a like a proper statement here, that plus or minus in there. So there are times when you can box up the equation and then box up what C is and say that, together that's the answer. But I need to be specific that I want the minus sign. Okay, so that's my answer. It's a function who satisfies that differential equation. No one does this ever, but if you wanted to check it, like if you're doing something like really important and like, the mission of the space shuttle like depended on it, you could take this derivative and plug the stuff back in and see if it works. And it should, but I'm not going to take this derivative and plug it. That's going to be a mess. What's much easier to check is to make sure this point works. So if I plug in 0, that wipes out. The square root of 16 is 4. Put the negative on there. So yes, the point definitely works. And there are times on the multiple choice worksheet and test where even if you don't know how to do the integration stuff, some of the answer choices don't work with the point. And so you don't even have to know calculus to check the point and at least rule out some of the answer choices. In fact, there's one of them that you don't even have to integrate. You can just plug that in, and it only works for one of the answers. Probably an oversight on my part. Okay, more practice. Number 2, dy dx equals negative sine x over 2y. Separate, then integrate. So let's move the 2y to the y side and the dx to the x side. The negative and the 2, either one could go on either side. We usually try to keep the constants off of the y stuff since we're solving for y later. So if you make y complicated, it makes your life harder later. So keep the negative on the x side. Usually we keep the constants on the x side as well, but this one will work out nicely. Let's see here. Because, Ethan, what's the antiderivative of 2y?
Just 2.
That's the derivative of 2y. Go the other way.
Yeah.
Who has a derivative of 2y?
It's going to be y squared over 2.
For y, it would be y squared over 2, but then that 2 is already there.
Oh, I see.
So the antiderivative of 2y is just y squared. Austin, how about the other side? What's the antiderivative of negative sine? Cosine. And then plus c. Oh, I guess I'll label it one more time. Separate, integrate, and then we're done with calculus. The rest is all algebra. So solve for y and find c. This one's a little easier than the last one, I guess. Plus or minus square root cosine of x plus c. I can tell already. Do I want the positive or the negative? Positive, because my answer is supposed to be positive, so definitely want the positive one. 2 equals square root cosine of pi over 3 plus c. So square both sides. Cosine of pi over 3 is 1/2. And so 4 minus 1/2, you could just put 3.5, 3.5, 7/2, however you want to write that.
Wait, don't you just square root 1/2?
I squared both sides right here
Oh, okay.
to square the square root. So my answer is square root cosine of x plus 7/2. And again, if you wanted to, you could plug all that back into the original. That would be a pain. you could at least check pi over 3 comma 2, and that'd be a little bit easier. Noah?
So to find c, could you not just use the y squared equals cosine x plus c?
Okay, this is a fabulous question. You can find c anywhere in the process. Just to keep it the same every time, I'm almost always going to solve for y and then find c, and then my answer is y equals something. But there are times, and this might be one of them, where solving for c before you solve for y is preferable. It's always okay, it just kind of depends on the problem. Number 3. Let's see, separate and integrate. So let's move the e to the x over. And then let's move the dx over. And then there's a negative on both sides, so why don't we just fix that before we integrate and just make our life a little easier. So there's the separate step. Now I want the integrate step. Yeah, whoever goes first is going to pave the way for whoever goes second. So I guess Jackson's the lucky winner. Victor, you get to go first. What's the antiderivative of e to the y? E to the y. Jackson, what's the antiderivative of e to the x? E to the x. Although on this side we want the plus c. Well, Noah brought it up, so I think this one might be a good spot to find c now rather than solving for y, especially if you look at your points. So, thanks to Noah, we'll do it, because it is going to be an easy one. I got e's, which is always weird, but c's got to be 0. So you saved us a few minutes with that question from earlier. So I'm back to e to the y equals e to the x. I want to solve for y. There's kind of an easy way and it's not a hard way, but it's a longer way around. If e to the y equals e to the x, we can natural log it. Natural log both sides. Natural log of e to the y equals natural log of e to the x. And that just means that y equals x, because the y comes down front, and the x comes down front, and the natural log of e is 1. And maybe if we'd really been paying attention, we could have caught that up here. If e to the y equals e to the x, then I'm pretty sure y has to equal x. That was a kind of a complicated problem for a relatively easy answer. Number 4. Let's see. I want to move the y to the y side, so dy over y, and move the x over, move the dx over. There's my separate step. Next we'll integrate. So Eric gets, I think, the harder one. JT, I think, gets the easier one, but we'll see. Eric, what's the antiderivative of dy over y? No. If you want to think of it as an exponent, it's y to the negative 1. And then if you increase the power by 1, you get 0, and divide by 0, that doesn't work. So the power rule doesn't work, so what's going on here? Somebody said it.
Natural log of y.
Natural log of y. JT, how about the antiderivative of negative 2x? So increase the power by 1 and divide by the new power. So increase the power by 1 to get to 2. Divide by 2 and then the 2's cancel. Okay, this is what I mean by this is all old news. You're supposed to know these. So if you don't know these, then this is going to be really hard. If you know them, then this is an easy lesson. All right, do I want to solve for C here? I don't think I want to solve for C here, because if I solve for C here, I've got natural log of 5, and I don't know what that is either. So let's solve for Y. So it's always, I guess, worth a look to see if it makes sense, but it would not make sense here. So let's solve for Y. So let's do the fishhook thing. E to the negative x squared plus C equals Y. Okay, now we're going to do some... Yeah, that was the fishhook to get to there. Algebra, algebra, algebra. Speaking of algebra, when you do x squared times x to the 5th, this is a little side note, you don't have to write this down, because you all know what x squared times x to the 5th is. Let me ask a dumb question. How'd you get 7? Okay. So normally we go this way with that algebra, because that seems to make the most sense. What would be helpful here, though, is to kind of go the other way, actually starting at this. If we added those together, it means that we originally had, or we could rewrite this as e to the negative x squared times e to the c. It's using the same algebra property, it's just using it in reverse. And why would we ever do that? Except that this makes this problem a lot easier to do it this way. Let's see, we don't know c yet. C can be anything, which means I could just take e to the c and say, you know what, let's just call that c. Because c can be anything, right? I don't know what c is yet. No, I don't know what it is, but I'm multiplying by e to the c, so I'm just going to put a c out front. This is definitely a bit of a trickery thing going on. It's similar to when we did c over 2 and just said, it's still c, it's fine. The good news is, now when I do 0, 5, oh, that's lovely. Right, because what's e to the 0? 1. So c is 5. Oh, here's one where if we wanted to be lazy, we could box up our answer with c and box up c and say, hey, the combination of those two things is our answer. So there was a lot of algebra in there. There was algebra to separate, and then there was calculus to integrate, but after that, it was all algebra the rest of the way. Lots and lots of algebra. All right, one more. Find the particular solution of y prime equals 3y plus 6. Given that, I'm going to rewrite that as a point. 0, 7 is on the curve. There's no x. Well, yes and no. Right? Like right now there's no x. Where is there? Y prime is the same thing as dy dx. So yeah, trying to get cute, but you were not fooled. So let's see. I think I'm gonna factor out the 3. That way when I move it over, I don't have to bring the 3 over. I'll just bring the y plus 2 over and have 3 dx on the other side. Just because that's going to make my life easier later. If you split it up with the 3 down here with the y stuff, that's fine. It's just going to make life a little harder. So that's separate. All of that was algebra steps. Now we get to do our one calculus step. What was that, Braden, for this side? Natural log of y plus 2. How about the antiderivative of 3? 3x plus c. You can put the c on either side, but since you're solving for y, you may as well put it on that side. Kind of like last time, do you want to solve for c now or
Later.
yes? Because the natural log of 2, I don't know what, or no, y is natural log of 9. I don't know. Let's fish hook. So here's our trick again. E to the 3x plus c is the same thing as e to the 3x times e to the c, which means let's just call that c and move the 2 over since we're solving for y. So there's my general solution. Haven't used that word since we started because it has a c in it. If we plug in 0, 7, we'll find the particular solution. It's nice when they throw in zeros. E to the 0 is 1. So c equals 9. So the combination of those two things is our answer. If that feels weird to write it like that, then you're certainly welcome to write it sort of out more completely like this. But you don't have to. Separate, integrate, algebra, 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 algebra. Solve for C, solve for Y, not necessarily in that order.
Is this all non-calculated?
Yes. All right, worksheet 1, 1 through 18. I'll answer a bunch of questions tomorrow because it's block day and slope fields are kind of fun. Maybe they look crazy, all those dots and arrows, but slope fields are kind of fun.